and short and long-term planning. All right, let's go through all of these one by one. So what is DevOps? Well, you probably know the answer to that. That's the reason why you are here. And the automation part of it that everybody targets, people think that automation is DevOps. Well, that's not it. And we started off with the waterfall model. Everybody knows about that. And then people kicked in agile, and that's where the whole problem started. We don't want to be getting into the pros and cons, but most of the parts we are encountering pros of that whole process. Now here, to run that kind of a process, you need smarter operations. Now, operations at all levels. I'm not just talking about operations at application level. I'm also talking about operations at your business level, and not just business and at application, but also operations as a whole, in your whole value stream pipeline. So what does it actually mean? All right, so what we were doing initially is we were building things in a very serial way. All right, so all the steps were in staged approach. So one stage, the second stage, the third stage, and fourth stage, and fifth stage, and so on. So people sometimes they refer to 5 stages, 6 stages, 7 stages, but it's all waterfall, everything happening one by one. And then came in DevOps. So DevOps says, I don't want to do things one by one, but what would I rather do is I would rather try to build everything in parallel. Okay, so your features actually they do trickle down. Okay, trickle down rather say, and this small thing that is trickling down here, let's call it that a small trickle. Okay, that small trickle is your small feature. And people have even broken down the features into very small areas. Okay, chain sets, a very small commit that can go out, but it has to follow the whole process. So the waterfall isn't dead. You have just reduced the size of it, and you have multiplied that by a factor of n. You know what's going to happen? You have to run all of these waterfall things again and again and again and over again. All right, so what can we reduce? So one of the most important aspects of being a DevOps engineer, so when you're running your DevOps setup, even before you could start planning for it, the most important part here is planning for it. Yes, when I say when you're planning for it, the most important part is how to plan for it. And even before, when you're thinking about planning, the important part here is figuring out redundancies. Okay, so the person or an engineer who is looking at the whole process should be able to figure out what is the redundant part, isn't it? If you're not able to find that pattern, if you're not able to find that repeat pattern in your whole process, you will not be able to make it faster. If you're not able to make it faster, you cannot save time. If you cannot save time, you cannot save resources. And that's the what do we call it? We call it return on investments, or ROI. People generally talk about these things. So when it comes to ROI on DevOps, yes, faster build process, shorter time to market, my applications would be deployed faster, there would be reliability in it, but at the end of the day, what is it actually giving you? So this ROI comes from the fact that anything that you do is saving time, and that time equals to money, and everybody knows about that, right? That's the whole thing. And when you plan about any DevOps things in your organization, you need to first be able to understand what that pattern is. Now, generally speaking, if you are in a software development industry, you would have a very common pattern wherein people would go through build, test, and deploy. All right, not in the same order though. You can have test before and then build and then deploy, and there will be so many other things that in between it creates your whole pipeline. It's called a DevOps pipeline. All right, fine, but what defines all these phases that are in between? So some of the complex pipelines that we have built, we saw that the actual step starts with checkout, and then we have to run some test. Let's call it unit test for now, and after that you go and do a build. All right, post build I would like to package it and that's the time that I actually create a deliverable or an artifact. All right, so you have unit tests, building, then the packaging of it, and post packaging you would decide on what's supposed to be done. Either you want to deploy it directly, you want to push it somewhere. All right, so you could, let's say, deliver or store it at some binary storage, wherever you would like to store it, just Sonatype Nexus or maybe Artifactory, some place like that. But post that, it ends there, right? And post that, it starts with another pipeline. So we have had some questions that it looks like a single pipeline, but it actually is two pipelines. And this separation of concerns will help you build things in a better way. So two pipelines. What are these two pipelines? One is the CI part plus delivery. Okay, so continuous integration and continuous delivery. I'm not talking about deployment. And then there is another pipeline that relates to the CD part or continuous deployment part. But this continuous deployment, it looks like a small word, but actually is the complete ops automation for you. All right, now there are two different kinds of approaches, or I wouldn't say approaches, I would say circumstances in which you build things. So the first one is Greenfield approach, where your project is not ready. You are actually building a pipeline for the very first time in your setup, and that pipeline would be used to support all of the features of DevOps. Now, when you have that kind of approach, you generally take short-term execution with long-term planning. All right, short-term execution means you try to get out as little as possible, but at the same time, you would like to span as much breadth as possible. All right, so what are you trying to do here is going ahead with implementation that connects to all the different parts. So when I say parts, what are these parts? And this is the whole idea of today's talk. How do I decide on what parts are there, and how do I identify those? Plus, once those are identified, how do I go ahead and build on top of it? Okay, so what are these parts? Let's say I want to have a Greenfield approach. We'll be talking about two different things here. One is Greenfield, and another one is the Brownfield approach, when I'm sorry, so there would be a Greenfield approach, and then there would be a Brownfield approach. Greenfield means you are just starting off, and the Brownfield means you already have a project. All right, so there are two different things, and in two different executions, we start in two different directions. All right, so let's see that. Here is your pipeline, a simple pipeline with build, test, and deploy. We'll take it simple first, and then we will explore what are the options and how we can grow these things, what are the things that we need. Okay, I would be connecting the dots, so I will be following the same pattern as we follow in what are we trying to do here is we are trying to follow the same pattern in which we implement the pipeline and deliver it. So same pattern is implemented in case of this section as well. So I will be kind of taking it as a evolutionary way, where we would be evolving the whole process. All right, so here it is, build, test, deploy in the Greenfield scenario, where let's call it green. I'll just mark it as green. Okay, so this is the Greenfield, and then there is another one, call it Brownfield. All right, so in the Greenfield approach, you actually start from the left. So you start with building, testing, deploying. So what you actually focus on is the CI part first, because your project hasn't started. It needs to be supported so that people can start using your pipeline for quicker feedback. All right, so let's write down some of the benefits of a pipeline that it gives us. So it gives us a feedback loop, right? It allows us to know what's the state of the code in a quicker, earlier fashion, isn't it? So the feedback has to be implemented at a CI level that starts on the left. So similarly, in the Brownfield, what would happen? In the Brownfield sessions or implementations, you would focus on the requirement, right? In this case, feedback isn't the first requirement. The requirement is bringing down the friction. So I'll say lower down the friction. So how do you lower down a friction in the brownfield? You actually start from right. Okay, that implementation starts from right. And since there are two different approaches here, from the CI as well as from the CD, isn't it? So you start either from the left or from the right, but in either of the cases, the approaches would be different. And since the approaches would be different, the features that you start implementing would be different. Now understand here that the long-term plan is same. You would be implementing a CI/CD pipeline, isn't it? DevOps, as you might say it. But that completely changes, because when you are starting from left, you are focusing on the developer side. When you're starting from the right, you're implementing things for the operation side of the house. Okay, because the code is then thrown from left to right. Let's say, let's draw a small line. This is the line of operations. Okay, this is the ops side and this is the dev side. So what are the features that you need for a developer? A developer would require faster feedback on his code, would require a faster feedback on any of the coding standards, would require faster feedback on his tests, would require some help in building this stuff. If it takes time on his machine, can it be implemented somewhere? Because it takes a lot of time. Let's say building takes about 30 minutes. Do you want a developer to spend 30 minutes on a system just after he has committed something and just wait? Because it's compiling. Okay, you don't want to do that. Exactly. So you have to support that kind of pattern with a separate system. Okay, so you set up some build engines for that, isn't it? That's the feature. Okay, that's how you figure out what a feature is. Now it might differ from projects to projects. Like in our case, we have a platform. We don't need to build anything. What we actually do is we get the code, we make sure that it is unit tested properly. Then we have to not build the code, but actually build the end system, the whole cluster, the whole platform, and make sure that each and every of its aspects are properly running. Imagine doing that on his system by a developer. First of all, it's simply not possible to grow things at that scale. Number of nodes that are required, number of containers that are required, setting up the whole cluster, and along with that, all the different tools that you cannot replicate. For example, if you are using some third-party tools, how would you get those third-party tools onto your system? You won't, right? And such kind of instances will make, or it not make, but it actually will push you in direction that that gives you a very different dimension in terms of setting up your pipelines. So here we start with CI. On the brownfield field, the target audience is the ops guy. What would make a ops guy happy? So let's understand those concerns. So when we get to the ops side of the house, what concerns them is the stability of the system, because that's where, if you believe or not, money is generated, isn't it? So money is generated on the ops side of the house, because whatever you build, if you can't deploy, if you can't connect with the people, if you can't deliver it to your clients won't pay you, isn't it? So if ops side of the house is there, there's no value to dev, isn't it? Now some people, they have been mistaken. They say, if I bring in complete DevOps, as in with complete DevOps, they mean if I bring in full automation, can I replace the ops team completely? Well, no, you need it because of the responsibilities in the house. You need people who are specialized in those execution of that particular responsibility. So for ops, how do you lower down a friction? Let's understand that. They have an SLA to be followed. SLA means the system should be up for so much time. So the older day SLA definition was to keep the machine up. The newer day SLA definition is keeping the services up, right? That's the mindset that has to be switched. So if you're talking about a service, it takes hard time to actually deliver this thing and get everybody on board that it's the service that you're after. It's not the machine that you're after. So stop scaring yourself if the machine goes down. And machine would go down only if something goes wrong. So what if you have a way to fix that something that is going wrong and not worry about that, but worry about your service? So there is a layer of abstraction that is now taken care of. You have a service, and then you have machines, isn't it? So here comes your feature for the ops. How can you not worry about a machine and just worry about a service? Okay, so that's the concept, high availability. That's one of the features that you could have in your pipeline. So lowering down the friction is actually by implementing high availability of your systems. And what about when the load grows? All right, maybe I also want to have scaling in place. That's another feature that comes in. Okay, so you mean to say that I would not worry about the machines. If the machine goes up, the still service is running, I can pop in another machine in its place and I'm good to go. And what about the scaling part? Sure, you can add as many machines as you want as your traffic grows, but who decides it? Wouldn't it be a person who sits there and then adds a machine? Gosh, it takes 7 days to actually configure a machine and put it in a cluster. Sure, that's the third feature that your DevOps pipeline should implement then. High availability, scaling, and then we are talking about configuring a system. All right, I'm not talking about tools at this moment. It's just the features that you're thinking about and you're actually writing it down. So there is no silver bullet called DevOps pipeline. It's not sure that you would need these features every time. You might not need to lower down a friction. You might not need high availability for your particular system. Might not need scaling, or your system might not support scaling at all. Something like a video bridge. So we are having a conference now. And video bridges, as they are known, in any of their configurations, they would hold one meeting at a time. You can't scale it. Can't scale it, right? You can't scale that kind of thing. Only thing that you can do is replicate. So you can increase your availability for different meetings, but you can't scale the individual meeting that's deployed on a video bridge. Okay. So not always you would need a configuration automation in place, but yeah, that was one of the requirements, because I don't want to spend 7 days to actually create a cluster and then add it to, create a machine and then add it to my cluster. That's the configuration. Okay, what can we do now? If I provide you with a solution that reduces these redundancies of configuration, high availability, scaling, and configuration, is the ops going to be happy? Would you then allow me to run any number of deployments on your system, because your SLA will not be hampered in that case? The responsibilities will not be on you if something fails. Of course, for the automation you are, but if something goes wrong, it's the high probability that it fails on the code. We don't need to tell them that we have implemented CI on the dev side, okay? Because we haven't right now. We are starting from the right side of, we are starting with ops first and then moving to the dev side. So they would say, okay, so if something fails, will the devs be responsible? Say, all right, they would be, unless we actually set up a good funnel for them as well. All right, I mentioned a term, funnel. What is it, funnel? Let's call it quality funnel. Okay, what's the quality funnel? Quality funnel will make sure that your artifacts, which are the most capable artifacts or most tested artifacts, move out. Others which have not passed all those funnel tests will not go out. It looks like a funnel. That's the reason why I call it as quality funnel. Okay, that's another feature that comes into picture. Okay, so let's talk about the dev side now. All right, so we have lowered down the friction on the ops side, tried to convince them that will all these features make you happy. They say, all right, but there are other places also. Okay, no, I'm not answering all the questions, but I'm trying to answer as much as I can. So here, let's talk about some more implementations. So what can we do? What more features can we think about? Let's see. So here, let's say we are implementing a quality funnel that I'll take you through. We have satisfied the operations with configuration, and they have one more question. I'll say, okay, we do have a CAB team because we are talking about a brownfield situation. So earlier, this change approval board, as they're called, or CAB team, they have a meeting, and during their meetings, they approve what should go out. Okay, and how can we help them? We asked. So they said, We can help them by making sure that everything that is going out is compliant to what they are supposed to be throwing out, because it's an enterprise level thing. All right, can you give me a list of all those compliance things? Well, they say, we never did that. We have an Excel sheet that needs to be filled up. Sure, you have an Excel sheet, but where do you put that Excel sheet? Do you enter it somewhere? Okay, we have a system called ServiceNow where we enter all of those things and create a ticket for that, and then they have a discussion. We raise some requests. Sure, let's do that. So what do you need from us? So before you can allow me to go and deploy, you want me to generate a change request every time I want to deploy? Okay, so how frequently would you allow me to deploy? So the answer would be like once a quarter, because that's when the CAB team has its rounds across the enterprise, and then it would be your turn to go and deploy. And what if I miss that deployment window? You miss it. You get a next chance next quarter. Sure, let's fix this problem. So what can I automate? I can automate a request. Okay, I can automate a compliance report. All right, and what else? Sure, things look good. If I have a compliance report and you can run all the tests with it and make sure that it is also having all the security aspects. What did you say? Security, right? So security, how is it built into system? So when you talk about security in DevOps pipelines, we have another term that comes up. It's called DevSecOps. People call it DevSecOps. Some people say there are various different terms people have coined for DevOps. And there's one DevOps, this one is NoOps. And so just SRE is just another one, right? But it's not equivalent to DevOps at all. That's a whole new different subject. Where you have SRE, you don't have Ops at all. Neither you have devs, most of the places. Okay, so it's a larger word. I won't go into that because that's not today's agenda. But here, people have coined different words. But what does it mean? If I have a word that I've just coined and I stick to it, does it mean that I'm living out on an important feature? Probably not, because you still have to implement that. Now, what's the reason that you have coined different words for that? It's okay, just because people find good about themselves. All right, so how do we implement security into the picture? Let's think. So that's another feature, all right? So we would be capturing all these features that we want to implement. So if I have a request generated, then I attach a compliance report with it and also have a security conformance report with it. Will the CAB be happy? And if the CAB says that, okay, everything is good, will they allow me to deploy? So we will be able to convince them. They say, okay, we can allow you to deploy once a week if you can give us all of these things, because earlier it would take a quarter or so for deploying. So all these features on the ops side helps us lower down the friction from the ops side when we start from the right. So what is the short-term and the long-term goals of implementing it? For the short term, you would think about how to integrate with ServiceNow and simply raise a request, right? Because the first things first, let the CAB approve it, right? And we implemented such things at one of the clients when we actually automated all of these things and let the CAB take a look at it. They were happy enough to get out of our way because the reports were generated so frequently, because it's automated, right? You can automate that. And then the configuration part, configuration management tool, you can use anything, orchestration management, configuration management, like Puppet, Chef, Ansible, SaltStack, whatever you feel like. Your high availability and scaling, we will be discussing that more when we actually build our infrastructure. We will see how the infrastructure should be structured for the more generic solutions. How do we scale them? And of course, all that leads to lower down the operation side of the house, the friction in the operation side of the house. That's what makes them happy. Okay, how do I make sure that devs are happy about these things? Devs are naturally the people who keep on building things. That's what they are paid for. Operations are the people who are naturally not allowing anybody to build things because that's what they are paid for. And everybody would like to do their jobs. Now here on the dev side, since they are actually running on the dev side, they are continuously building things. Let's see what we can actually do on the ops side of the house. All right, let's do that. So here, let's see. At the top, we have got some feedback. So we need feedback loops in place. We need tests execution in place. All right, I would be executing the tests. And what I need to do, I need to build things. Sure, what else? Oh, even before you send me a feedback loop from the pipeline, can you actually do the same thing on my system? What do you mean? So even before I commit, can I know that my code is actually compliant? Can I know before I commit that everything is right so that people don't shout at me when the pipeline breaks? Sure, let's think. So it brings us to another notion that pipeline doesn't actually start on Jenkins, isn't it? So people would be implementing things on Jenkins, Circle CI, I don't know, Cloud Bees, hosted versions, deployed versions, whatever. But yeah, your quality and also the DevOps pipeline actually starts when your code starts, maybe even before that. So how do you set up your dev environment is the first question. Okay, and how do you catch code problems on the developer machine itself, if there are any? So maybe code analysis. You don't want to run the complete static code analysis on your system, but that's a good place to start. Okay, how do you do it? Commit hooks, pre-commit hooks as they're called. So there are so many different features that we have just listed out. Let's see if we can talk about this and how do we implement this with different tools in a pipeline. All right, I'll keep that screen here open on the right hand side so that you know that we are implementing all these features. Okay, and the implementation will go in two different levels, short-term and long-term planning. Okay, I hope we are making justice to the agenda today. So the agenda, as I repeated, it would be how to plan infrastructure components, how to plan tool placements in pipelines, planning features for users, and short and long-term planning. Okay, so let's see how to plan infrastructure components now. So based on the features that are required for your particular project, then you would decide on the tools. And after the tools have been decided, you would find a place for them to settle down in your infrastructure. So provisioning is different, configuration is different, and drawing an architecture of it is again different. Okay, so let's kick in. So we've already seen that we can start in two ways, left and right. Okay, short-term planning about these features. If I want to implement a CI for the developers, how do I do it? Now for the developers to start things, I don't need code analysis straight off the bat. Okay, I can still trust my developers, but what I want is to automate something. That automates something is something that is redundant, that happens every now and then. And the most important part of it is called testing. Manual testing, most of the times. Can you automate that? Sure you can. Do people love doing that? Only the guy who would feel the heat would love doing that. But yeah, we do it. So for the testing part, if I automate the testing, how does the testing funnel would look like? Let's say I take you to the funnel and then we can talk about the tools and the pipeline. Okay, my drawing is not that great, but here's the funnel for you. And this funnel has various different filters. What does the funnel diagram actually mean? It means that for all the changes that are coming down from the top, so all the commits that the developer is making in the pipeline, not all those commits will trickle down. Okay, they will not trickle down, they will simply end here. Only a few might pass, and this is your production. All right, what does it mean? It means that the rate at which people commit, all right, so let's say the rate at which people commit will slow down as we pass from dev to production. It should go down like this. Okay, that's the graph. If you plot a graph, it would look like this. So here, not all the changes go. And for these filters, what are these filters? These filters are the tests that you execute at different levels. Okay, so the first is, let's say you have your unit tests running. I would just call out names for the sake of understanding. There's a whole big pyramid that you can run full of tests if you want to, but just to give you an idea. All right, so we start with unit tests, and then we have let's say you are running in an environment, your unit tests, and post that integration test. I run integration after deploying it in an environment. So integration test happens after a deployment, and post that I move that same deployment into another environment. Let's call it, I run it a stress test there, okay, in the staging environment, maybe something more kind of a functional, or you can even run load testing if you want. The tests keep on changing, increasing the complexities of it, and at the last we have, if it goes out well, we run smoke. You can also run regression and all that stuff, okay, it can also take into place. So all these things, they actually happen in a cycle. The cycle is of test and deploy, okay, test deploy, that's what keeps repeating. So this funnel never lets all the changes go out. If it does, your funnel is not strong enough, okay, that's a negative sign. Your rate should go down, all right, not because you don't want to deploy, just because the number of jobs that fail at a particular filter should give you an idea about the strength of that filter. If nothing is failing at that filter, that means something is wrong at that level, okay. That's why it's called a quality funnel, and the funnel only lets a very small change trickle down. That means your frequency of deployment is not directly proportional to the frequency of development. When people say that I have a CI/CD pipeline that runs at the speed of development, dude, it doesn't actually deploy at speed of development. If it does deploy at a speed of development, something is wrong, all right, something definitely is wrong. Okay, so let's see. So we had a funnel, we implemented that. Now we want to plan for the tools. Now tools directly connect to the features. If you have a feature defined, you can relate that to a particular tool. All right, I want to set up a dev environment. What if I give you a kind of a setup that is closer to your production units? Can we have dev environment set up in such a way that your Docker containers can run the code as and when it's changed? Sure, it can. So you can have a script that runs inside a Docker container that scans the directories that are loaded inside it, and it will automatically build and showcase the responses. It's very easy to be done in case of a front-end development where responses are supposed to be faster, the feedback is supposed to be even faster. Okay, so that closes the feedback loop for you at the developer side, your dev environment. So you choose some tools like that. You might differ, okay, I'm just keeping a couple of names because we would like to showcase them in the infrastructure setup. How would they occupy a place there? So code analysis, let's see, I want to run something local, okay, and for code analysis, so can I have something, if I'm working on Python, so that's, since I'm from a DevOps background, I work more on that. Of course other languages will have their own setup. So instead of PyTest, I would like to use PyLint. That gives me a first-hand analysis on code. So how good my code looks, is there any syntactical problems, will it actually run, what is the status of code smell on it. So am I actually writing which is completely away from the standards? We like to follow standards so that code is more readable and it is consistent across development, different developers. So PyLint would be something that you can get for quicker code analysis. I'm not saying static code analysis, no, that's a completely different part. All right, if you need a static code analysis into your system, that's yet another feature that you can build in. So Docker, PyLint, let's say called static code analysis also if you want to push something in. SonarQube. Okay, I want to have feedback loops. Sure, feedback. How do I get a feedback? What is the fastest medium of receiving a feedback? Can I get a ping on Slack, or the age-old method of getting an email sent to you? But how frequently should the feedback loop execute, and when should it execute? If I get a lot of emails about all the kind of feedbacks that I receive, I won't even see those kind of emails anymore, right? Which will cause issues. So it needs a thoughtful planning about feedback loops. Of course, at every level in the pipeline, whether it would be build, test, deploy, or any stage in the funnel, you can generate an email and send it to a person who caused it. Sure, you can, but you won't send that email every time. You would only send it when the stage flips. What does it mean when the stage flips? I would like to actually refer to it as state change. What is a state change? So when it changes from success to failure, or it changes from failure to success. So when there's a switch, I want a feedback loop to be generated. Sure. Do we have systems that does it? Yes, we do. And there are so many other things that we can actually run, right? So we have Docker, Pipeline, SonarQube. Feedback loops are generated by default by any of the CI systems that you want, but where do you want to send it? That's the question. All right, so the same setup will be executed everywhere. You want test execution? Yeah, great. I am a person with Pipeline, so I would be using PyTest. If you are a Java guy, use JUnit, use something else if you want to. Building. Now this also does packaging for me. Okay, these steps are more or less generic, but you can differ or bifurcate from it and come back also. So you can run pipeline in parallel if you want to. If you're a guy who is building middleware that needs to run on Windows, Linux, Mac OS, but you're writing code just one time. Okay, and the binaries are created across the platform, so you can run the pipeline in parallel so that it bifurcates at the time of build and then packages them in different formats. You don't want to run it in sequence that, okay, if Windows is done, then I do with Linux. But what if Windows fails? Then the Linux guy will never get that execution done, right? So that's the reason when you branch out. So that's another possibility or a feature implementation. Okay, you have that. Cool. So I would be using Docker for my build and packaging, okay, at the same time. So try not to involve so many technologies, but at least the same amount of technologies is good. You don't want to say that I would be using RKT for packaging and I would be using Docker for my dev environment. You don't do that, all right? You don't want to do that. So stick to consistency level of the tools. Now for the security part, when we say DevSecOps, how can we involve security into picture? And at what level? Okay, let's see. As we pass through these features, I will also mention some security implementations on this side, on the left. Okay, so we have packaged everything, and I would like to stop at this level because that's the logical separation of dev and ops boundary. So security implementation. Here, for the DevOps, starting from the dev end, the security starts right from the system on which the code is being executed. Okay, what is it? So when I write my code, I want to be knowing that packages are compliant. It starts there, okay? I don't want to be simply doing pip install something without knowing what is the security concerns of it. All right? Okay, so what do I use for that kind of things? We use package scanning, and there are some tools for that. So package scan tools, something like even JFrog, or even if you use Nexus Sonatype, both of them would give you that kind of a tool that runs right inside your IDE and gives you the alerts right there. So the security starts at home, right? And it doesn't have to build on top of your DevOps pipeline, it goes in the DevOps pipeline. So here, so we start with JFrog. What's the next stage? We tested, we have SonarQube, sure, it would be doing all the scans. And since we are doing static level scan, it also makes sense to have code level scan done for security and packaging if somebody is not following things on his dev end. We don't want to leave everything to humans because we tend to miss things. I wouldn't say knowingly, but unknowingly. All right, there's a high chance. So we have something like Veracode to do that thing for us. All right, so we are building things on a security aspect. We'll move ahead. We are testing. All right, packaging. Okay, and what if I want to do a security test on my application which is being packaged? Sure, something like Twistlock can help. So which checks for the packages, okay? So there are different systems. Now in this case, I'm using Docker, so I would be generating an image as an artifact. So Twistlock would be able to scan that image for me and actually give me an idea of how things are working inside the image, whether it is compliant or not compliant. So my security guys are happy. So thinking long term, all right? So short term thinking was, how can I get my developers' code outside? The long-term planning is, when they get their code out, how can I still make it compliant so that the cab board that would be hitting my way down the road should not block me there. Otherwise, I'll have to go back and do the complete rework. I'll have to go back and say, dev guys, that whatever you're doing, you need to stop doing that, because I'm going to insert another code level scan here, let's say Vera code, and you will have to go redo the code and make sure that all the scans are green and all of your packages are. But if people were not ready for that kind of change, it only would mean breaking pipelines, which means that your funnel will not even be passed at the first level, isn't it? That's the long-term goal. Short-term, you simply focus on your CI, moving ahead. So post Docker, packaged it, added that to a delivery place, let's say added that to ECR or any container registry for Docker. Images are there. All right, what's next? Want to make cab happy. So I want to be able to run a request. Sure. Can I integrate with ServiceNow? Okay. Can I have a plugin? Sure, there is a plugin. So can I integrate with that plugin and run a request? Absolutely. That's one thing. Second thing, can I get a compliance report? Remember, we started off early with security, generating all the different compliance reports that we have. So we have a compliance report for JFrog, we have a compliance report from Veracode, we have a compliance report for Twistlog. My cab is a happy guy now, because they know that if I'm going to release these things, they are actually compliant from the norms that are supposed to be followed. Great, what does the impact report now actually say? I have it on ServiceNow, so it tracks all the code plus connects it to the tickets. You can use Jira, okay? You can use footprints, whatever you like. It's not just ServiceNow, but just to give you an idea that all these things are interconnected, right? Your code with your changes and your packaging is all connected, and that connection also goes back to follows on till production, where you are releasing. So your release tags will also be connected. So you need a way of connecting all these things back. It is called auditing, and that's one of the very important features if you want to make cab happy. All right, so we have all those changes in place, and those are trickling down every single job. So the cab is a happy guy. What do we do next? We have an approval. We can go and run configuration on the systems. Before running the configuration, I need to be able to get a system that can be configured. Okay, provisioning. You see there? I'm using a tool called Ansible. Okay, why I picked up Ansible? Because it runs on any cloud I want to. If I pick up a tool that is very focused, and then people would say, all right, I don't work with that cloud, and what's the next tool? So Ansible here would help you with provisioning, as well as you can use Terraform if you want to, and then help with config as well. So I have this tool now, Ansible. Now remember, all these tools, we would be seeing how to implement these tools in a pipeline. Docker, Pylint, SonarQube, you have Slack, email, PyTest, Docker, ServiceNow, or Jira, whatever you want to use, and then Ansible, and then you have your cloud systems. You would be then configuring it for high availability and scaling, maybe some features from a cloud provider, or build it something all by yourself, completely up to you. Auto scaling is the answer. Remember, there's a system, so you can actually choose between three. So either you can have either you can have high availability, or you have scalability, or you can have consistency. That's another thing. You can choose only two. You can't choose the third one. All right. So if I choose between, if I choose for high availability and I choose for scaling, it means I will actually end up with a system that is eventually consistent and will not hold consistency between those different shards or nodes at all times. Very good example, social networks. Okay. If I choose between HA and consistency, then scaling would be a problem. An example of that would be your relational databases. If I choose between consistency and scaling, then high availability is an issue. Okay. So that's another thing there. So make sure that you understand that these concerns are always in picture. All right. So, all right, auto scaling was the one that we considered. We are good. We want to have the deployments done. So we configured, provisioned, configured, set up things in auto scaling, and did a deployment. Okay. I did everything. But now, according to the SLA, I want to make sure that things are running fine, and I also want to make sure that I have a complete trace log of everything, which is an audit. Okay, so to generate an audit, I need to have data. What is there? Where is the data going to come from? For all these things that are running in the system, you need to cover them with monitoring and logging and tracing. Well, there are three aspects to observability. If you are wanting to do a complete audit of your system, there are three items, not just monitoring. Okay, monitoring would tell you the current state of your systems, whereas logging would give you a past state of your system and also allow you to run analytics on top of it, whereas tracing will give you a complete root cause analysis, or let's say for an application, a complete trace of what is happening through the application at every level would be generated. Tracing also refers to any of the changes that are going in the system, not just from auditing, but the request, even if it is flowing through the system, how it is hopping between the different nodes. That's the tracing part for you. Okay, remember, I brought in this point at the last because it grows on top of the complexity that is already implemented. You simply don't go and start building things right away, all right? So you have to plan for all of these things. Fantastic. With all of these items in picture, how do we get started? That can be overwhelming. Let's see. Give me a minute. We can wrap it up in another 10 minutes or so. So there are so many items out there that we built, and we have also seen a decision-making process behind it, all right? It's not just that we build it for the sake of building it, but now we know that why do we need it? What's the reason why I'm building these things, and who is the beneficiary of it, and why is it required? So it's a big gamble out there. It's not simply a green CI/CD pipeline that people think that if I put in Jenkins and add some jobs and stages and things are going to be good. Okay, let's build things. I need a happy person. So I have a client whom I want to be happy. Okay. So client is accessing my system, and he's accessing a system from a production environment, let's say, and I have a machine there. Okay. So these are my machines. So I have these boxes on which my applications are running, and the client would like to access these machines. And since there are multiple machines, you would think, okay, since there are multiple, where would this client go and connect? Isn't it? What do? You set up a load balancer on top of it? Sure, it's requirement based. It's not simply because you want it to be there. You have a reason why it is supposed to be there. And people sometimes take it for granted. And when they take things for granted, the unlearning process becomes difficult. Okay, not always you would need a load balancer in place. Load balancers sometimes can do more harm than good. Okay, there are instances where you would not want to have this kind of systems. So you have a load balancer that connects to multiple systems. Okay, that's fine until this point. What else? From this item here, which is my web layer, I would like to connect to another layer that's my DB. Sure. What else? My users also generate some requests on the system which cannot be fulfilled at the same moment. So I would need something that runs in the background, and I would call it a batch system. All right, so batch will have its own machines and DB will have its own machines. Okay, so the separation of concerns are there. That's a good thing. And the systems would then connect as a load balancer to these batch entities now. And these batch entities will interface with other entities in the system via another load balancer, isn't it? All good. So that would be taken care of by provisioning, but I also want to have auditing in place. So that's just one teeny tiny portion of a production environment. Okay, it's not done. Your job is not done. There's a whole big world to it. Let's consider monitoring. And this is where the actual pain point starts. So the largest cost that is incurred after your compute is storage. Okay, even if you don't need it actively for production, you need it for auditing and monitoring purposes. So this monitoring things, all of these machines that are out there, they are generating some events all the time. Okay, and then you have your monitoring segment. Let's say you have a here, a load balancer, and then you add the data somewhere. Okay, there will be so many different moving pieces there. How you do it is irrelevant right now because it would change from tool to tool. But again, you would have some servers, okay, for monitoring, and you would be adding these data, the data to these servers. So all of these machines which are in your production unit, all of them actually generate information, and they throw that information away from them real time. So even if when they're connecting to one another, what they're actually doing is they're throwing information out to the monitoring guy, and the monitoring guy is all busy collecting everything and dumping it down. So here are very important things. You need to have a very good indexing rate, and you have very good storage. All right, and it's not all done, right? It's not all done. You have monitoring, then you have analytics. So there is a consumption that is done from this information that all of the machines are generating, and your analytics will generate a nice dashboard for you. Right, that's an analytics part. So monitoring, analytics, your monitoring and logging goes hand in hand. So it's not always data, but you also have the data goes in your data dumps or data, but you also have a system that generates real-time indexes, something like Grafana, from indexing timeline like this, and then analytics will pull in. So that gives you a view of what is happening across the wall on the production side, isn't it? That's how it's all built. Okay, is it enough? It's not enough. There's some more things that are required. All right, so I drew 4 quadrants. So what's in the next 2 quadrants? This quadrant here is called a tooling quadrant. All the DevOps pipelines that you have seen, all the environments that would be there, okay, all these things are juggled or managed from this particular section, which is the tooling area. All right, and that's the most important one, because here is the entry system. Entry system as in this is where you enter into the system. So the Bastion machine, if you have one, would be attached here. This is the place. Okay, this is the entry point. You don't enter from any other places. You don't enter from the client side. You don't enter in the logging and monitoring area directly. You can only enter into the tooling area. That is why I built it this way. It is more secure, isn't it? We limit the number of entry points into the system, and also limit who can enter into the system. If they need an entry point, they get entry point directly to the machine that they want to enter, and also not at the root level. Okay, so for the monitoring, I want to see the dashboard. Sure, you don't need a Bastion server in that case. You probably need a VPN that connects you from the entry point to the VPN to directly to the analytics site. That's all. All right, nothing more than that. And I have the whole control. So what's in tooling? In tooling, you have your Jenkins, your Ansible, okay, Terraform, anything and everything that you need to support all of these machineries out there, to control the operations of these machineries. That's your tooling cluster. And then you have the other quadrant. This is where your developers play. So all the environments that you have, all right, so maybe you have your dev environment, you have your QA environment, you have your UATs stuff and whatever, right? All these environments run in this part here. So why a separate section for these? Because these environments also generate information that are thrown across the wall to the monitoring site, and that's how you keep a record of everything that you want to record, okay, and run analytics on top of it so that people know what they're supposed to be knowing. So these analytics now then can be also added behind some authentication systems so that your developers can see their views. So if a developer comes in, he sees his view of system, so he's bounced back from the auth for the information in dev and QAs, whereas a person who comes there for analyzing the operations side on the operations aspects on the client side, they jump back to the production unit. So that's how it is all structured, right? It becomes more complex because that's what your bird eye view at a long-term planning looks like. So this is what you want to build, okay, and you want to start small. So what are the aspects that you actually build? You start small by fixing these 4 quadrants at first, and you don't scale up. You start with anything that is at hand, and then you grow accordingly. What is important is the data flowing, all right, and your feedback loops that come out of it. What you use for it is irrelevant. So to begin with, if I want to start with Ansible, because that does everything, and Jenkins having just one single job of creating all these machines is fine for me, works, right? It's all good. Instead of all 3-4 environments, I just have one environment that's throwing information to maybe just one single ES or Elasticsearch data store in the monitoring area. That's fine. It's okay, right? And in the production side, I don't want LBs on everything just yet. I just want one machine because I just want separation of concerns to begin with. And then you can grow it at enormous level, but at a high level, your quadrants look like this. Your production may not be as simple as the one that we have drawn here on screen. Okay, it could have various different layers, but that's all is the takeaway for today. So what have we covered? We covered how to plan the infrastructure components. What are the requirements of placing them in 4 different quadrants? We learned about how to plan tool placements in pipelines based on the features, not because somebody has implemented the tools in that particular sequence. The sequence might change. Third one was planning features for the users. Let's identify who the users are and then what the requirements are. And based on the requirements, how do you get your point out? At the same time, making sure that they are the point of focus for you, making them happy in their own fields, in their own boots. And how to plan long-term and short-term so that you don't get into positions of complete rewrites again and again. When you don't plan for the long terms and you start just getting things implemented as soon as possible. Of course, that's important. Short-sighted implementation is very fast and very much required. But if you don't have that vision, you will have to rewrite those short implementations sooner than later, right? And we don't want ourselves to be ending in that kind of situation. All right, so that was everything. And thank you so much for your time and your patience being with me on this call for so long. What we have done is we have also shared some form with you for feedback. So you can let us know how you felt the session went. Let us know what you feel about having some more sessions related to that, where we can show you these things live in implementation, how the tools are actually implemented, how they work, how is the data flowing to the things, how to build your own setup. All these kind of follow-up talks can emerge from a small talk like this. All right, we are waiting for your ideas. Thank you so much for your time. I'm signing off. My name is Ashish Nanotkar, and I hope to see you in next sessions as well. Thank you.